Hello everyone, and welcome to the NEATEC Electronics Series. This episode will concentrate on frequency. So let's get started. So what is frequency? So basically frequency is a repeating signal. And we want to know how often it repeats itself, right? So if we look at this, we simply draw a simple timeline here. And this is, call this time. Okay. And this here, this over here, this is simply going to be amplitude. Now suppose we have a basic signal. This is a sine wave. You can tell I'm drawing it by hand. And then this just continues on over this way, right? So what we want to know is how often it repeats per unit time. So if we look at this point right here, you can see the signal has an upward slope, right? And it just crossed the zero line. This is zero amplitude, right? This line I drew here. So it went up, it came back down, has a negative slope, it crossed the zero amplitude, came down, and guess what? Comes back up. Here's where it's crossing again. This has a positive amplitude. Again, came up, came back down, it crossed the zero line, on its way up, bam, crossed again, and it just repeats, right? So here's the thing, frequency, all right, can be thought of, or actually it's defined as cycles per second, okay? Now, if you look at this graph I drew here, this chart, the time t from this point, let's draw this down here, to where it started, just going to draw a little arrow here, that time is the time it took for one cycle, right? Now, if you notice we had one cycle in this amount of time. Suppose this was equal to 1 second. I'm just going to put this in parentheses. 1 second. So we would have the number of cycles is one cycle in 1 second. That's equal to 1 cycle per second, right? Which is equal to 1 hertz. By the way, that's generally the shorthand for it. I think that's pretty much how you spell it. Hertz is right here. That's the shorthand for it, okay? So what's going to happen instead of 1 second, suppose this was 0.1 second. What's it going to be then? Well, let's go through the same thought process, right? Let's just bring it right down over here. So it's going to be 1 cycle, still the same number of cycles. That hasn't changed, right? But the time, instead of 1, it's going to be 0.1. So it's going to be 0.1 seconds, which is going to be equal to 10 cycles per second, which would equal 10 hertz. Get it? Now, here's something interesting. What happened? Well, there's several interesting things to talk about here, but this time right here, the time it takes for a cycle to repeat itself, that is generally termed as the period. And that is usually represented by the letter of capital T, okay? And basically that is going to be equal to 1 over your frequency, right? So if frequency is measured in cycles per second, then T, I'm going to call it your period, is going to be measured. Did I write that right? There it is. Period. It's going to be measured in seconds per cycle. So in other words, the period is going to be measured in seconds. Frequency is going to be measured in 1 over seconds. Okay? That's a very clear distinction you must have, all right? The second thing is, remember frequency, we use terms to refer to frequency. So you may hear the term 1 kHz or 1 kilohertz. So if you have 1,000 hertz, that's going to be equal to 1 kilohertz, which usually is represented as 1 kHz. All right? Here's the other one that's going to be useful. If you have 1,000,000 cycles per second, that's going to be equal to 1, anybody have an idea? It's going to be 1 megahertz, which is going to be equal to 1, it's a capital M, hertz. The kilo, I've seen both small k and a capital K used. I don't think that's an issue, but mega is always a capital M, so make sure you remember that. So that is the discussion I wanted to make sure we started with, to make sure everyone understands when we're talking about frequency. If we use the term 1 kilohertz, 10 kilohertz, 100 kilohertz, you know what that means. Well, let's just do a quick discussion here, right? Let's try this now. All right, everyone. Let's try some problems, shall we? Just a few basic problems to make sure that everything is understood, right? So this is how I recommend you do this, is I'm going to write the problem down, we'll talk about it, and then you can pause the video. Then you can give it a go yourself, give it a try, and then restart the video, and then we'll solve it together. All right, so let's do this. 10,000 hertz equals how many kilohertz? All right, give it a pause now and try it, and then turn it back on, and we'll solve it. All right, welcome back. Let's take a look at it. So we have 10,000 hertz. So 1 kilohertz, that makes sense. 1 kilohertz over here, right? 1 kilohertz equals 1,000 hertz, right? So obviously, right, 10,000 hertz would be, let's just write it here, 10,000 hertz is going to equal 10 kilohertz. Okay? Pretty straightforward. Now look, just think about it. If you have 20,000 hertz, 30,000 hertz, 40,000 hertz, it's just going to be 20k hertz, 30k hertz, 40k hertz. K is 1,000. Pretty straightforward, right? Now, you're going to run into that a lot. So suppose you have something like this, 1,500 or 1,500 hertz, right? Well, that's going to equal 1.5 kilohertz, right? 1.5 kilohertz. Obviously, if you multiply 1.5 times 1,000, that's going to be 1,500, right? Okay, so let's try the other side. The same thing. If we have, let's say we have 3 million hertz. That's going to equal how many megahertz? Pause the video and let's give it a try. Okay, welcome back. So we know, what do we know, right? 1 million hertz equals 1 megahertz, right? Got it? So 3 million hertz is going to equal 3 megahertz. Now let's try this. What is 3.5? Let's change it. 3,500,000 hertz. I'm sorry. That's going to equal what? Well, that's going to be 3.5 megahertz. Right? Now, remember, this M, and it's a capital M. This is a capital M. That right there equals a million, right? So 3.5 times a million is, well, 3.5 million, right? It's the same thing over here. This K, that equals 1,000. All right? So this is 1.5 times 1,000. It's going to give you your cycles per second, or your hertz, and that's what we have right there. The point is you're going to hear the term kilohertz and megahertz used a lot in your study of electronics. I just want to make sure that everyone understands what that means. So that's our discussion on frequency. So thank you for listening, and see you on the next episode.